For this question here, for this past paper question, it's kind of difficult to spot the topic of the question. So, because we're given the gradient, we're given the equation of the curve, you should be thinking differentiation. Now, if we talk about the gradient, let's think, well, what do we know about how to find the gradient? Differentiating the curve, the function, gives you the gradient function. So here's our curve. It's a cubic graph. Let's differentiate by multiplying by the power and taking 1 off the power. 3 times 4 is 12. Take 1 off the power. X to the power 1 becomes x to the power 0, which is 1. So it just leaves 12x squared minus 8. Now, that is a gradient function. That formula will allow us to find the gradient at any point on that curve. It says find the x coordinates of the 2 points on the curve where the gradient is a third. So because it's a cubic curve, like there are going to be more than 1 point when the gradient is a third. Let's just bear that in mind. So if we're going to put the gradient function equal to a third, because we know the gradient is 1/3. Okay, let's now solve this equation to find x. I'm going to add 8 to both sides first, which gives us 12x squared is equal to 8 1/3, which is the same as 25 over 3. I'm just going to write it as an improper fraction. Let's divide both sides by 12. So 25 over 3 divided by 12, x squared is equal to 25 over 36. And let's now square root both sides. But don't forget here, when we square root, we've got the positive answer, 5/6, and the negative answer, minus 5/6. And the question says, find the x coordinates of the 2 points on the curve where the gradient is third. It's just x is 5/6 and x is minus 5/6.